Alright, this is over scientific notation. You're going to be using this a lot throughout chemistry, and you'll use it again in physics. A lot of it should be a review from math class. And then why are we going to learn scientific notation? Because we use scientific notation to represent numbers that are very large or very small. Remember, this is chemistry. We talk about atoms. We're going to measure and count atoms that are very small. So this is why we're going to use this. Now, scientific notation looks like this number right here, 5.25 times 10 raised to the 60. So that's what it's going to look like on paper. Now, when you go and start to calculate these, don't ever write it like this in your calculator. It will give you the wrong answer. Instead of doing the times 10 raised to the 60, you're going to use this function, this EE function right here that covers the times 10 raised to whatever exponent you're working with. If you can't find it on the calculator, normally it's above the x minus 1 button on your calculator. And you're going to have to hit second, x raised to negative 1. You'll see the EE on there. If you can't find it on your calculator, bring your calculator up to your teacher, and they'll show you where it's at. But on your calculator, if you wanted to type 5.25 times 10 raised to the 60, you would type it 5.25 E60. Don't do the times 10 raised to the whatever. That will give you a different answer at certain points throughout the semester. I know it says EE right here. You only have one E there. That's what it's supposed to look like. I don't know why it changes, but it does. But this is a lot of writing, but you need to be able to know these rules and state these rules if you're going to be working with scientific notation and decimal forms, because sometimes you'll be given one and have to work with the other. So to convert from decimal form to scientific notation, you're going to move the decimal point so that only one non-zero digit remains. And then the exponent's number of places that you moved the decimal point. I'm going to show you guys how this works. It makes a lot more sense when you see it. But just go ahead and write these down for now. Please pause to write this down if I'm going too fast, but I'm going to go ahead and move on. Okay, going the other opposite direction, from scientific notation to decimal form. You're going to move the decimal point to the right if the exponent is positive. And you're going to have zeros that you're going to have a bunch of spaces that don't have numbers in them. That's going to happen. When that happens, just add zeros to those empty spaces. If it's in front of the decimal or after the decimal, it doesn't matter. Just put those zeros in your empty spaces. Then move the decimal point to the left if the exponent is negative. Now, sometimes we work with a problem. You'll be given scientific notation that you're going to have to correct, especially when we're talking about significant figures. Yes, they do matter here. So that's what's going to govern if you have to correct this or not. So when you have to correct this, you're going to move the decimal point so that only one non-zero digit remains to the left of the decimal. Then however many digits you have left after that, that's governed by those sig figs that I was telling you about. So you can increase the exponent if you move the decimal to the left. You're going to decrease the exponent if you move it to the right. And once again, this makes a lot more sense once you get into it. So I'm going to do numbers 1 and 3 again, and I want you guys, once I'm done with those, to pause and go through numbers 2 and 4. So we're converting 1.1 times 10 to the 3 decimal form. We have a 3 here as our exponent. It's a positive number, so our number is going to get bigger. So we're going to move our decimal point 3 places to the right. So we do 1.1, we go 1, 2, 3. And that's our new decimal point. Well, now you have these empty spaces here. That's where those zeros go. So your answer is going to be 1100 decimal. You can see how our number of significant figures have changed from 2 sig figs to now we're at 4 sig figs. Okay, then number 3. Now we have a negative 3 at our exponent. So negative 3 indicates we're going to make a smaller number. So we take 1.12. Okay, we're going to move it to the left. Go to the left. Move this one to the right. 3 spaces. So 1, 2, 3. Now our new decimal place is right here. We have 2 empty spaces that we're going to fill with zeros. So that number becomes actually 0.00112. We had to add the 0 here because it has to have a place there. So go ahead and pause it. Work through numbers 2 and 4 on your own. We'll come back and correct your answers or make sure you're right. Now let's practice on these. Once again, I'll be doing 1 and 3. You guys do 2 and 4 on your own. So we're converting 75,100,000 to scientific notation. We're going to start with our decimal point. Decimal point is really right here. So how many times are we going to go? 1, 2, 3, 4, 5, 6, 7 decimal points to make sure we have one non-zero digit remain to the left of the decimal point. So we moved 7 times So it's going to be 7.51 times 10. And then we have a positive number here, so it's going to be times 10 to the 7. Number 3. Now you're going to move it one non-zero digit to the left of the decimal. So how many times you get to move to do this? That's 1, 2, 3, 4, 5, 6 times to make that 2 to the left of the decimal point. So that makes that 2.31 times 10 to the 6. Now we move the decimal point to the right this time, so it's going to be a negative number. So you can see, if you can double check yourself, the positive 7 is a really big number. So big. The negative 6 was a really small number. That should keep you straight. So go ahead and pause the video, do 2 and 4 on your own, see how you do. Okay.